No break. And we'll finish early.
At 8.
Yes, at 8. At 8. If you're good.
No.
You're always good, mostly. Right. Next lesson.
Projectile.
Projectiles. You remember this?
Yes. Bye bye.
Yeah.
Why bye bye? Is it hard?
It's not hard,
It's
but
not hard,
it
but
makes us very
It's difficult to understand sometimes. Yes.
it's very uncomfortable.
no. Bye
Confusing
bye.
maybe.
It's uncomfortable, yes.
Bye bye.
Very bye bye.
Yes.
Okay, so projectiles.
No.
Easy to say bye bye.
Okay. Next.
Yes.
Okay. Yes. Yes.
Is it lesson 9?
It is, I think. It is lesson 9. Exciting. Yes, yes. Alright, so what is a projectile? So a projectile is an object that travels through space with only one force on it, the force of gravity. And the path it takes in space is what's called parabolic. So the shape will look like this. You see, it'll kind of move in this hill shape. But you know this, if I throw something to you, it will move like a hill shape in the air.
But in space it doesn't, it's not that way, right?
I suppose I should have said space, as in like on the surface of the earth, space. I understand what you mean now, yes. Yes, that would be outer space, I guess. Although, I guess even if it wasn't outer space, we still call it a projectile. It's something that you throw. Because the verb project also means to throw. So the noun for project is projectile. You got this?
No.
No, my goodness.
Because my writing is
So slow?
beautiful.
Oh yes, of course. I
My
realised I have the same trousers as Amanda today.
yes, same color.
Same colour trousers.
Yes,
Yeah.
Yes. Blue?
no, black.
Mickey Mouse.
Mickey Mouse.
Mickey Mouse?
Star Wars shoes.
Alright. You got this?
Like
No.
my brother writing English like a flower.
His writing?
Yes,
All nice.
very nice.
Very nice, like a flower. Okay. Continue?
Yeah.
So here's a picture. This is what I mean by a projectile. Sorry, a parabolic path and a projectile. This is a projectile. Once the bicycle leaves the ground, there's only one force on it. Gravity. The only force is gravity. True, there's air friction, but we'll ignore the air. Okay? So I just wanted you to see a picture of the motion. That's all. Okay, this is not a projectile. This is Superman. Why is he not a projectile?
Because
He's
he's
not
he doesn't exist.
human in the earth.
True, he's not human, but there's another reason why he's not a projectile.
Because he's not being thrown.
True, yes. Superman is not a projectile because he travels whatever way he wants. So there's not only one force of gravity, there's other forces too. So he can have an up force, a forward, a back. A projectile has only one force, going down. So he's not a projectile. Okay, so some things to note for working with projectiles. The dimensions are independent. Gravity is only on the y-axis. There's no acceleration in the x-axis.
But there's deceleration, right? Oh no, but we don't take into consideration.
No, you can still call it acceleration even if it's slowing down. Vectors can be used to resolve the projectiles into an xy component. projectiles have no vertical speed at their maximum height. And remember, S is position, not distance. And I'll say it again. Well, no, I won't. So please make note of these 6 points to remember about projectile motion. Got that? Grace has finished first today. Okay, you have that? Yes? So let me explain each of the points. So the first point, the dimensions are independent. Okay, so take something that's not independent. So there's x and there's y. So let's say I have, I don't know, like a rope here and it's swinging around. So imagine, let's say it's here, and then let's say it's here, for example. So look, this x is getting smaller, and what's happening to the y?
Getting bigger.
It's getting bigger, and then when the x is 0, what's the y?
The
Not the highest, yeah? So this is an example where the x and the y are not independent, that they have a relationship. But for projectiles, this is not true. So when this is moving in space, the x value here and the y value here, these are independent. There is no relationship. In other words, the movement here does not change the movement here. They are independent. Next, gravity is only on the y-axis. So that means in the picture, the gravity is only here. But there is no gravity in the x part. Here, the gravity is only in the y part. So for the x part, there's no acceleration. You can get the x and y by using vectors. So for example, here, if you know the speed you shoot it at, and if you know the angle you shoot it at, then you can know what the x speed and the y speed is by using vectors. There is no vertical speed at the top. So when the ball is up here, there's still a speed this way, whatever, 10 or 100 meters per second. But at the very top, this is 0. There's no vertical speed at the top. And remember, S is position. Let me just double check you have that idea. So let's say this is 100 meters, and this is 100 meters. So 1, 2, 3, and here at the top is 100 meters. Okay, here, Fx, Fy, 0 and 0. Here, Fx equals Fy equals. What do you think Fx equals here, roughly?
50.
50. And Sy?
Maybe 90.
Yeah, well, I didn't draw it nicely. 100 it was supposed to be. And then at the end here, Fx and Sy, I'll do a different colour. Fx and Sy. What's the Fx? 100. And the Sy?
0.
0. There is no height.
Mm.
Okay. You don't need to draw this. If you want it, if you find it helpful, you can draw it. But I just want to make sure you get the idea. Can I continue? Yep. Okay. And I did some showing here. Alright, so let's have a look at our first example. A projectile is fired, so you can write it down. It's fired at an angle of 30 degrees and a speed of 100 to the horizontal. What is the time of flight? What is the range? What is the maximum height? Okay, got it? Let's have a look. Alright, so let me try and draw it beautifully. Okay. What's the speed, did I say? 100, was it? 100 meters per second? And the angle? 30. So what you can do is get this one and this one. How big is this one here? 100. Good. 100 cos 30. So this one here is 86.6 meters per second. And then the other one, sine. So that one here is 50 meters per second. Sorry, this was 100 cos 30 and this was 100 sine 30. Okay. So it goes up and down and then crashes here. Right, what was my first question? Time of flight. So what I mean is how long until it hits the ground? Okay, got the idea? So for these you want to look at the y. So imagine here as the ball is moving in the air, you only look at the y-axis. What would you see happening? The ball's height increases and then it reaches a maximum, and then it decreases until it comes all the way back down to the ground. So if you were just looking at the y, u, v, a, t, and s, the u would be 50, the v you don't know, the a is minus 9.81, the t you don't know, but the s you do know. Vertically, what's the s?
Uh,
0.
oh, yeah, because it goes up
Yeah,
and then down.
goes up and comes back down. So let's say I'll use s equals ut plus a half at squared.
But there's two S's, right?
There's a horizontal and there's a vertical. So right now we're just looking at the vertical.
Okay.
So s equals ut and then a half t squared. So then you get 0 equals 50 minus 4.905 t. So then t equals 10.2 seconds. That's okay?
Yeah.
Now what's the next question? Is it the range or maximum height? Or the range. So the range is the distance it travels here. This is called the range. So now we should look at the x. Look at the x part. So the u is 86.6. The v we don't know. The a we do know, it's 0. Why is the a 0? Because it's horizontal. No gravity. The t we do know, we worked it out, it's 10.2 seconds until it hits the ground. So I can now get s equals ut plus a half at squared. That's gone. So the s would be 883 roughly meters. So that's the range. The range is 883 meters. So for this part, you're only looking at what happens along the x-axis. So if you look at the x-axis, the ball just keeps moving to the right, and then it suddenly stops. If you were looking at the shadow, it would just move to the right.
Wait, what's the A0 again?
The A0,
Oh, because, yeah, never mind.
I like it when the students answer their own question. It makes it easier for me. Okay, so is that B part okay? Right. Now the C,
Okay, can you go back?
yeah, the C part is maximum height. So do we look at the X or the Y? What do you think? X or Y? Look at the Y. So what's going to happen is it's going to increase, and then at the top, the V in the Y direction is 0. There's no vertical speed. So you have U, V, A, T, S. U is 50, V is 0, A is minus 9.81. I want to know the S. V squared equals U squared plus 2AS. So let me see. Squared divided by 2 divided by 9.81. So if you put the numbers in, you get S equals 127.4 meters, so roughly 127. So the maximum height is 127 meters. Isn't that what I wanted? Maximum height. Yeah. question, Grace? You look
I'm looking
confused.
for your H.
This is my H. You like it?
Yes. Not, no, this.
No,
Sorry,
okay.
no.
You got that?
Yes.
Okay. I wonder if I can find something here. Projectile, motion, laser, 2 dimension. Uh, um, no, never mind. Okay, next. Okay, so write this one down, please. Yeah. What's wrong, Grace?
Hungry.
That's a good thing.
Yes. Heading for home.
Yeah, me too. It's only 12:25 though.
Yeah. Bye bye.
What time are you finished at?
2:50.
2:50. My
Mm.
goodness. What's wrong with you? So you have lunch after this class?
Yes,
Yeah.
and 1 hour cycle to train and go home.
Yeah.
再见.
再见.
Ah, you're so lucky. What are you complaining about? Oh my
But
goodness.
We
but
are
on
we are
Thursday,
busy
but in
on
Thursday
Yeah.
on
you can,
Thursday
yeah,
and
in Thursday you
Wednesday.
can have one class and nothing to do.
And no time to
Nothing to do.
no time to eat breakfast.
Yes.
No time to eat lunch.
Busy, busy.
Very busy.
I don't know about that.
With the signal?
Yeah.
Okay. I didn't
You
read.
understand my you didn't read my
I
story.
didn't read. And the writer a long time.
Okay, can I do it now?
No.
Ah,
Or half minute.
half a minute. Okay. Quarter minute.
Okay.
Yeah. All right. So I'll draw my picture. So grass, building, boyfriend, and girlfriend. Okay, so she is 25 meters away, and she throws the,
But it's impossible.
maybe, maybe my numbers are wrong, yes, maybe. 25 meters per second. The angle here is 60 degrees. So the first thing we'll do is we'll get the x and the y. So
It's in Boston.
25 cos 60. So here is 12.5 meters per second. 25 sine 60. 21.65 meters per second. And I also tell you that here the height is 1 meter. That will be important later. Okay, so my first question was what? The time of flight, was it?
Yeah.
No, I forgot what the question was. I
Time
didn't
of
write
flight.
it. Yeah.
So, should you look at the x or the y here?
The time is the Y.
Well, in fact, for this one, it's much easier to look at the x
Oh.
because I think it is. You know the u. What's the u? 12.5. 12.5. The v, you don't know. The a is 0.
It's one.
This is the x actually. X. The a, what's the a?
0.
0. The t you don't know, but the s you do know is 25.
Yeah.
So just by using what do I want? The t, you can get, well, whichever formula you want to use. S equals ut plus a half at squared. The a is 0. The s is 25. The u is 12.5. So what's the t here? 2 seconds. So you know the t is 2. Is that okay? Now for the b part, we should look at the y. Because for the b part, I want to know what's the height here. The height. So now I can say u, v, a, t, s. What's the u? 21.65. The v, we don't know. The a, minus 9.81. The t,
Um.
2. The s is what we want. So if I use s equals ut plus a half at squared, let's see what I get. 21.65 times 2 minus 4.905 times t squared, which is 4. So I get s equals 23.68 meters. Is that the height?
No.
No, what is it?
Minus 1.
Plus 1.
Alright.
Oh.
Sorry, plus 1.
Yeah. Because what you're doing here is you're making this,
I'm so sorry.
does it make sense?
Yeah.
You're making this here the x-axis and this here the y-axis. So your height of 23 needs an extra 1. It's okay? So the boyfriend is at 25 meters high in the building.
Wow.
Yeah, amazing.
Mm-hmm.
Okay,
Why is he flying?
what's that?
Why is he flying? It's more from.
Because it's at night and he's asleep
You can just text
Oh.
him.
and it's a secret
Mm-hmm.
and there's no battery.
No gravity.
Yeah,
Yeah, and the windows broken.
yes, yeah. Alright, next question.
No, 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 no.
No, how many questions are there?
Oh.
There's a few more.
No.
Why?
Alright. Um, you know what? I'll probably delete some of these.
Yeah.
Let me do this one. Okay, so you write this one down, please. Ah,
Yes, it's 8. No homework.
maybe. We'll see.
I have no more paper. Yeah.
Yeah, maybe there's too many examples in this one.
Yes.
But you find this one difficult. That's why I want to do more examples. Or is it,
Ah.
or is it easier now?
Easier now.
Is it?
Yeah.
Really?
Yeah, maybe.
Maybe. We'll see how the homework goes.
Oh my god.
Bye bye.
Yeah, bye bye.
再见。
再见。
Shay shay.
谢谢。
Ni hao.
Yes.
Ni hao ma.
我很
不
好。
好。
不好。
不好。
There's only one thing I know in Korean. Barista.
배고파. What's that?
That's all I know. What's that? Oh, you don't remember our last lesson last week?
What?
Barista. The
Ah.
person that, yeah, okay,
Ah.
yeah. Okay, we'll do this example and then
Finish.
we'll finish, okay?
Yes. Okay.
Then you can have your lunch and then your one chemistry class and then you can go home.
Yeah. Very good.
Too good, too good.
Why you want to be a teacher?
I don't know. I ask myself that every day. It's not for the money. It's not for the students. I don't know why.
You can be a physicist.
Maybe it'd be better. Too dangerous, maybe.
Why? No,
Something explodes.
that's chemistry.
Yeah, that's true. Yep.
No.
No.
No. Oh, goodness. I want my lunch too, you know, I'm hungry.
Me too.
Yes,
Me too.
me too.
The range is the Y, right?
No, it's the X.
Okay, sorry.
Oh, so I know it sounds weird, the range for flight, but the range always means the X.
Okay.
Do you have breakfast?
Yeah, I did.
Yes.
And you're hungry?
Yes.
Yeah.
Good.
One sandwich.
Just one?
Yes.
Oh, that's not enough for you, I know.
Yes.
Ham sandwich?
Yes.
Yes.
And cheese.
And cheese?
Yeah.
And
As usual.
ketchup.
And
As usual.
as usual. This is your new breakfast.
Yeah.
Yeah.
Every day.
Every day.
Last time we have pizza every lunchtime
Pizza?
Yes.
Nice.
for 2 weeks.
For
Yeah.
2 weeks.
Every day. It's pizza.
So lunch
good.
is
For
pizza.
lunch every day.
That's good, no?
No good.
I thought students like pizza.
No, not for 2 weeks.
Okay.
Every day the same.
Maybe not for 2 weeks. Maybe 1 week.
Yeah.
Yeah.
Yes. Home say little brother's father think it's very cheap and buy.
It is very cheap.
And
And
delicious.
he didn't eat.
Yeah.
So you had to eat it.
Yeah.
Oh, he got it for the little brother.
Yes.
And the little brother didn't want it.
No.
So you got it.
No.
No?
His father think it's cheap, so buy.
Ah, okay. Okay. Terrible.
And eat it 2 weeks.
Two
Pizza.
weeks.
Pizza.
Can you
Every
finish
day
it?
pizza.
You can have something else today. Okay, so for this one here, how big is the cliff? 400 meters. And here's the car. And then the car goes like this. Fly away indeed.
Like a line.
And the speed of the car is 36 meters per second. Right. So just be very clear. Look, here the x is 36, but the y is 0 because the car is going horizontal. Right. Number 1, the time until it hits here. So, should I look at x or y?
X.
Why?
Why? Oh, we don't know the X distance.
Yeah, y. So u, v, a, t, s. What's the u?
The U is 36.
V is 0.
Oh,
Zero.
zero.
Yes.
Oh my god.
V, we don't know. A,
Negative
minus
9.
9.81. T, we don't know. F,
0.
S is for
Ah,
negative
minus
100.
400. That's what you were going to say, Sophie? Yes. So let's get the t. S equals ut plus a half at squared, right? Yeah. So minus 400 equals minus 4.905 t squared. So I got t is 9.03 seconds. Okay, B, I would like the range. So I want the range here. Should I look at the x or the y?
X.
X. U, V, A, T, S. What's the U?
36.
V, don't know. A,
Don't know.
0.
Alright.
Yeah. T, 9.03. S is what we want. So again, S equals ut plus a half at squared, but the a is 0. So you get 3 to 5.1 meters. So the range is 3 to 5.1 meters.
Why don't you cancel the other side?
The a is 0.
Oh, okay.
Yeah. Okay, next. Yes? What was the velocity when the car hit the ground? So I want to know the u. But I want the u for the x and for the y. I want both. So we'll do it in two parts. The x and the y. U, V, A, T, S. U is 36. V is what we want. A is 0. T is 9.03. And S is 3 to 5.1. U, V, A, T, S. V is what we want. U is 0. A is minus 9.81. T is 9.03. And S is minus 400. What would be the easiest formula to use here? I think just V equals U plus AT.
Mm-hmm.
So V in the X and then V in the Y. Okay, so V equals U plus AT, so you'll get 36 meters per second here. And V equals U plus AT.
But we don't have to calculate for the V for X.
I know you don't, but I'm just doing it for fun.
And the other one is also.
It should be the same.
Okay.
So, can I go down a little bit? Can I go down a bit? Bit more? Yes? Yes? So when the car hits the ground, it's going this way with 36 and it's going down with 88.6. This is the velocity. 36 horizontal and 88 down vertical. For the last part, I want the speed. What's the speed? Well, the speed is how fast it's going. The speed is this one. So it's like the opposite of what you did at the start. It doesn't matter.
Is it a car?
Yeah.
So is it
Yeah. It's just going to be square root. So part D, 36 squared plus 88.6 squared equals 95.6 meters per second. That's the speed. That's how fast it's going when it hits the ground.
Just hit the ground, it's not the.
Yeah, you don't care about the x and the y, just the speed it hits the ground. Yeah.
Wonderful.
Oh, it is, isn't it? Can I go back?
Yes.
Don't worry, I'm not going to do another one. I can go back?
Mhm.
Yeah. So, we won't do this example. Yeah, that's okay. That's okay.
Okay.
Maybe I'll put these examples in the homework.
No.
Oh.
Okay, I'll tell you what, I'll put one of them in the homework.
Thank you.
Try
Any more?
again.
Maybe I'll put this one in.
Okay.
Uh, maybe. Take a picture and then go.